Greetings, everyone. Joining me on today's Next Gen North podcast is Dr. Nazim Nassar. Dr. Nassar is a pharmacist, a medical researcher, and has recently registered a patent for a cutting-edge medicine delivery system. In this episode, Dr. Nassar takes us through life in the Middle East, his journey to the territory, and his groundbreaking medical research. We hope you enjoy the episode. Yeah. So, Dr. Nazim Nassar, I should say. I'll try to get that one right. Thank you for joining us on the Next Gen North podcast. Really appreciate you being here.
Oh, thank you for having me here.
So we've run into each other, passing on the street. So I'm really glad that this podcast is finally happening.
Yeah.
Do you work nearby, or are you in the new CDU building, or what?
No, actually, I was walking towards the bus station. I'm taking the bus every morning to Casuarina.
Oh, right. So it's all the work's still done.
Yeah,
from that,
all the work, all the health section like pharmacy, medicine, and health sciences in Casuarina.
Yeah. Okay. Is that getting moved into the new CDU building at all?
I think the new CBD building will be hosting more law and accounting.
Okay.
Yeah.
Oh, so you don't get the flash new.
No, I would like to,
and all that sort of stuff.
All the labs over there.
Is it all right if I call you Naz?
Of course. That's my preferred name, actually.
Great. So where are you from originally, Naz? If you don't mind?
I was literally born in Nazareth.
Wow, there you go.
And grew up in a town near Nazareth, but Nazareth is my, where I was born.
Yep.
And that's in Israel. In northern Israel. So, and from there I lived in Nazareth, or in that part of the world, for 27 years before I migrated to Australia in 1996.
Wow.
So initial studies happened at the Hebrew University. I did science, measuring physiology. Mm-hmm. Then I moved to Haifa, where in the Technion, Israel Institute of Technology, and I did my second degree in pharmacology. I did work in the hospital there. I moved to Tel Aviv. I worked 3 years in a pharmaceutical company associated with Lundbeck, the Danish company from Denmark, working on antipsychotics and gynecological products. But during that time, when I was doing my master degree, my supervisor, he was originally from Sydney. He's an Australian, Jew-Australian.
Right.
And we had some work happened at that time with Professor Angus from Melbourne University. But at the same time, we also had some work. I worked on heart contractility and weakness of heart muscles that develop during or because of certain liver disease, including cirrhosis. And that type of work also was conducted in Toronto in Canada. So since that time, I was interested always to pursue studies in English-speaking country. I love English.
Okay.
English my third language, and always I feel like always I felt like I want to develop this language.
Right.
I want to do well in it.
Yeah. Is that third behind? Is it Hebrew and
Arabic?
Is that the two national languages?
Two national languages over there, and obviously because I was born there and studied there, and my background as a Palestinian from that part of the world, as indigenous people living in that country. Yep. Of course, I mastered Arabic and Hebrew as well. So English third language in Israel, and we don't really, especially during the 80s and 90s, we didn't have access to a lot of technologies that we have today. So in general, Israelis, they were not, the best, let's put it that way, when it comes to English.
Sure.
And always I felt intimidated by that, because I love the language. I want to deal with it. You deal with the pharmaceutical companies. So I started thinking going to Canada, but then talking about climate, weather, safety, type of people, tolerance, all those sort of things. And thinking future, we're going to have family and kids, I thought, after a bit of study, I found Australia probably the best destination for me, and that will happen. But it took me a while to get into Australia because you have to go through a lot of tests and to see if you are qualified to migrate to Australia. During my studies, I worked in a medical laboratory in a hospital. So I was qualified as a medical laboratory scientist, and that what qualified me to come to Australia as a qualified migrant.
So it was like a skilled
migration.
migration.
That was in demand, but not as a pharmacologist. I was in pharmacist even at that time. And I received a phone call directly from the embassy telling me, if you're a pharmacist, we'll speed up the process because definitely they need pharmacists here. And all the time, pharmacy was in demand. But then I said, no, but I worked in hospital, and that what helped me to get into Australia. But it took me a while. It took me about 3 years.
Right.
So in 1996, by that time when I applied, I was single. By the time they accepted me, I was married with 3 months old baby.
Oh, right.
So we came to Australia, and I landed in Melbourne, and since that time, we lived in Melbourne. I also did some studies. When I arrived, I went to Professor Angus at Melbourne University. He noticed that my English really still need a lot of work. So he said to me, we cannot offer you a job at university, like to give you a scholarship based on that as a tutor, for example. So he suggested, why don't I go and find a part-time job and do my PhD as a part-time? Then I was lucky enough to get accepted to Monash University Pharmacy College. And at that time was exclusive, was till today, Pharmacy College in Melbourne at Monash University is last year was #1 worldwide.
Wow.
This year is #2, and it's like the mark, the cutoff is very high, but I was very lucky based on my previous qualifications. So I did pharmacy, worked in pharmacy from 2000, graduated in 2000, worked till 2009. Then I established my own pharmaceutical companies as a distributor. I worked with aged care all around Australia. I worked with the Gulf region, exporting medical and pharmaceutical products from Australia. Everyone wants Australian products because of the TGA. We have very high standards.
Right.
And I had my own pharmacy till 2016. But during that time, I went back and I approached university again for my PhD. Always I want to pursue my PhD. And I was lucky enough, but then they said, well, your last degree was more than 10 years old, so you need to do some sort of studies prior to your PhD. And the condition was I have to have high distinction, and that's what happened. I did go back and I did my honors degree, and then I went to a PhD. And I was lucky enough to get a pioneer supervisor in his field. His name is Stephen Kasapis, Professor Stephen Kasapis, who is a biophysicist and a food scientist, and where we utilize some of his skills and technologies to develop a new technology that we're here to talk about it today. So then, I was in Melbourne for a long time, for 28 years.
Yep.
I studied Monash and RMIT. My wife, the same thing. She did a couple of degrees at RMIT University. My daughter finished as a journalist in La Trobe University, and my son, he is an aerospace engineer finishing this year at RMIT University.
Wow, distinguished family.
So that's what we've done. But about less than a year ago, I've got this offer coming from CDU, and my nature, I have a very high risk appetite.
Okay.
Always I like changes and knowing new people, knowing new places. And I never been to Northern Territory. I've practiced pharmacy as locum pharmacist all around Australia. That's how I toured Australia, even while I was doing my studies and my lecturing and research at RMIT. Every few months, I used to take 3-4 days, go to Tassie, go to Western Australia, to Central Queensland, Central New South Wales.
Wow.
I knew Australia very well through my work as a pharmacist.
You're probably not better than most Australians, to be honest.
But I never been to the Northern Territory, and always I was interested to see what's going on here. I read a lot about Northern Territory, and I felt like it's a different country. And it is a different country when I came here. So, and that's why even like I still don't have a car here, because I like to go with the locals, go in the bus, to know the people, to learn about this place more and more. And that's exactly what happened. So I feel like, I'm part of this place now.
Yeah.
And at the moment, I'm a lecturer at the CDU, so I'm teaching pharmacy students. And also listed there as a supervisor, principal supervisor for HDR, or for what we call him high degree by research, masters and PhDs. And hoping we will get some grants and some money for a lot of, for interesting research happening there, or will happen. Part of it to do with what we call it biopharmaceuticals,
right,
which is based on peptides and proteins, or biologics, what we call it today, to treat debilitating diseases such as cancer, diabetes, chronic disease, wound problems, chronic wounds. But also, and that's also to be one of my specialties, is a delivery scientist or delivery system or pharmaceutical scientist, where we tailor customized delivery system for these biologics, because of their sensitivity and because of their maximize the effectiveness, reduces side effects by targeting target cells. And also, I worked in the past on cannabis, on CBDs to treat melanoma, and we achieved with my previous PhD student from RMIT very, very impressive results there, where we managed to stop growth of melanoma cells, or what we call it, inducing self-killing mechanism of these cells by introducing an extract of, or specific extract that been developed for that purpose from CBDs. That's basically my research, and that's my area of interest when it comes to this.
Great. Before we get sort of a bit deeper into the work you're doing, you say you've only been in the territory for about a year, was it?
9 months.
9 months. And what have your first impressions of the place been?
Very, very. I was very interesting. First of all, probably I arrived in the during the wet season.
Okay.
And
bit of a shock.
Honestly, I didn't like that, but it wasn't really strange for me. In Israel, I lived in Tel Aviv and I lived in Haifa, and even a couple of months before I arrived here, I went to visit the family in Nazareth. And we have similar similar conditions when it comes to July, August, the tough summer, humidity very high, and temperature soaring to mid-40s sometimes can get. So it's so I wasn't really, but I prefer dry weather, dry heat.
Yep.
Melbourne is great. I love Melbourne. That's one of the reasons I stay in Melbourne all the time. I don't mind cold weather during winter, but summer is nice, summer. And it's exactly the same I experienced in Jerusalem. We have exactly the same conditions, and I loved it there. And these two places where normally I have this allergy in my throat, I develop cough. There's the only two places that I never had this case, Melbourne and Jerusalem.
Wow, there you go.
Yeah. Here, back again, sometimes I start experiencing it.
Is it like a pollen or something, do you think?
Yeah. Most likely that's the case. And normally when I take antihistamine, that helps me. Yeah. But so when I arrived to Darwin, didn't but everybody, quickly I made friends.
Right.
Lifestyle is beautiful. Too many tourists here, and I love that.
Yeah.
People more relaxed. You don't have to worry too much about what you wear, who you talk to, where you go and having a beer or something. Yeah. So I love that thing. And but now during dry season, it's a great place to be in.
Have you been to all the, the tourist traps here? Been to Litchfield National Park,
National Park,
the jumping crocs and all that sort of thing?
I've got a very nice, very good friend from, he's a local.
Okay.
His name's William. So, he's a great guy, and he made sure, within months, I know pretty much all places around Darwin and the Northern Territory, so we've been traveling a lot.
Yeah.
Fishing, going around, experienced pretty much everything. So during these 9 months, I learned a lot about Darwin. Mm-hmm. Probably to get to know, compared to Melbourne, probably took me 3 years.
Right.
To get to the stage there where I'm here now in Darwin within 9 months.
Yeah, great. So you've come to be familiar with the place. So obviously, the territory is quite a seasonal place, with tourists and that sort of thing. Is that quite similar to somewhere like Nazareth? Do you guys have a lot of tourists there? Is there religious pilgrimage, that sort of thing?
Of course. Yeah. Nazareth and Jerusalem, in general, that part of the world is a lot of history. We're talking about the oldest city in the world is Jericho, and it's in that region.
Right.
In the around the Jordan, or between Tiberias and the Dead Sea was the Jordan Valley.
Right.
So it's the oldest city in the world. So you see things there you don't see in Europe. Oh, probably in Europe you can. Yeah, you see that. But it has unique characteristics because of the spiritual connection. Many civilizations been there over the last thousands and thousands of years, and that's why we're experiencing so many, territorial people over there now. That they instead of thinking about peace and prosperity and good future for everybody wants everything.
Right.
Unfortunately, but we have also people who are want to reconcile and to stop this what's happening there, and it's just because of the heritage that we have there, the richness of the history that and the civilizations that lived through millions of years in that region. So that's when it comes to why people wants to go in there and see what we have. In Australia is different. Probably, it's a great country. It's a great nature, great people, safe. A lot of people look at this, and the weather allows this year. We don't have a very harsh winter or too much in summer.
Yep.
In the main, in down south or even here.
Yep.
But it's different, probably in Nazareth or in Israel in general, in the Middle East. We have similar climate conditions to Western Australia, where you can experience 4 seasons during the year. But we don't have 4 seasons in one day like we have in Melbourne.
Yep.
Or in Northern Territory, we have 2 seasons, basically, wet and dry.
Yes.
We don't have these things over there. So you have distinguished seasons, like when it comes to autumn, winter, summer, and spring. So you have 3-4 months of each, and distinguished by temperature and humidity and plants and everything, and food, type of food and clothes. So you over there, you put your winter clothes in the cupboard, and it's in all the time there until next winter.
Right.
Where in Melbourne you have to have your umbrella and your jacket and your shorts in your car.
You never know what to expect.
You never know what to expect.
Yeah. It's a funny place, Melbourne. I really like it. I go there for the football. I try to get there yearly. But I've been to music festivals and that sort of thing, and 1 second it's 40 degrees, the next minute it's
it dropped by 15 or 20 degrees.
Yeah, and sleeting rain, you can't dress for that type of environment.
But it's a great place.
Yeah.
It's so beautiful, and always I feel homesick.
Yeah, right.
Especially my family there, so I'm by myself here.
Oh, they didn't come with you?
They were overseas, so we just managed to get them back from, what's going on in Israel and the war.
Did they get caught up in it, did they?
Yeah, my wife and my daughter.
Oh,
but my son, because he's studying still in Melbourne, so they're staying with him at the moment.
Yeah.
But currently I'm by myself here. So, but my wife will join me soon.
Okay. We've got, pretty old culture here in Australia as well, tens of thousands of years it goes back.
Yeah, true.
What can you explain, and a lot of people come to Australia to visit for that reason, to experience that spiritual significance of the place. Can you explain, for those that may not know, the spiritual significance of a place like Nazareth?
You mean like what we experience over there? Or
what's the story? Like, I know it's tied to the home of Jesus and that sort of thing, but is that sort of how you still view it?
Yeah. Look, if you look at Nazareth or Jerusalem or any, we're looking at most religions were born there. Like if you take Christianity, Jesus was born there, so we call him a Palestinian Jew.
Okay.
That's what was before. He was born in Bethlehem, but then around Jerusalem. But when he grew up in Nazareth. And everywhere you go there, what you see in terms of, what do you call them, churches, or it's related to
places,
that era,
places
where he was.
Yeah.
Where he was, if you go to Jordan River where he was baptized, if you go to Nazareth, and if you go to Jerusalem, and you see all the holy places, churches, now churches, they were there. Same thing with Islam. Muhammad was in Al-Aqsa Mosque. That's why it's a very holy place for Muslims. He was born in Mecca or in Saudi Arabia today, but it's all one region, one small place, probably much less than what we have here in Australia in terms of size.
Yep.
Moses, the same thing. Was born in Egypt, and according to what we know from history, managed to get his tribe or the Jews out of Egypt to Palestine at that time, or to what's called today Israel.
Mm-hmm.
Or so it's all these people lived together for thousands and thousands of years, and practiced different religions, converted between different religions. Like there is a new historian now, an Israeli historian, was saying that originally the Palestinians in Palestine or in Israel today,
mm-hmm.
or even in Gaza on the West Bank,
right.
Originally they were the original Jews, but they were converted to Islam because Islam moved from Saudi Arabia to different areas around the Middle East and Europe, and to escape paying al-jizya at that time, what we call it, which is like a tax. If you're not a Muslim, mm-hmm. You'll be exempt from that if you convert
right.
to Islam. So a lot of Jews converted to Muslims at that time. And if you look at the similarity in terms of the color and the way they look, not much difference at all between Jews coming from Northern Africa, mm-hmm. who migrated with Muslims all the way, like when they moved around, and the Muslims they live in, or the Christians and Muslims they live in Israel. We see a lot of people like Caucasians, Jews. They converted from and they came to Palestine at that time.
Yep.
So it's a lot of mix. What I'm trying to say is a lot of mix. So same thing when Christianity was born in that region. A lot of followers, they converted from either Judaism, mm-hmm. which which is an older religion, or later on from other Muslims.
Right.
So by the end of the day, people live there thousands of years ago. Probably they were cousins or brothers, but they're now different religions, and some of them, as I said, like, trying to conquer everything, and some say, well, let's share it.
Yeah.
And I think that will be the best option.
I think you can get caught up in the lore and the history of the place for hours and hours, can't you? It's so rich.
There's no end for it.
Yeah.
It's a conflict for thousands of years.
Yeah.
You can't solve it within, during our talk.
Well, it's interesting, like I've traveled fairly extensively myself around the world. I never got to the Middle East. I really wanted to go to Israel and to Tel Aviv in particular. But the Israelis I met around the place, like mostly probably in South America, I found were extremely patriotic and almost had their guard up a lot of the time when talking about sort of geopolitics and that sort of thing. Is that your experience of Israelis, and why do you think that is?
Look, it's tell you something. Let me give you an example here, what we experience in Australia, and from there we will understand exactly what happened.
Great.
In Australia, everybody loves Australia, and not just Australians. People from outside Australia wants to come to Australia because it's far, because it's a lot of opportunities, because it's a rich country, beautiful weather and everything. But you see Australians here, they're happy to go and live anywhere else in the world. But why is that? Because there's no conflict, and there is no need to feel like, somebody is going to take this land of you.
Interesting.
Right? Now, in other parts of the world, they don't have this experience. So you like, one of the things you can, you live in Melbourne, for example, 28 years, like myself. Easy for me, I'll come, or my son who was born in Australia, to leave Melbourne tomorrow and come and live and buy another house here and live in Darwin.
Yeah.
Or even go to Germany and live in Germany.
Yeah.
And a lot, they do that. Over there, because of the situation, either because they are religious people, and it's not just the Jews, the Muslims, the Christians, if they are religious people, of course they're going to stick to to the Holy Land. So they feel and that's why you feel they're very patriotic, because, as we said, every prophet or was there.
Right.
And there was something for Jews, there was something for Muslims, and there's some for Christians in that part. I'm talking about Israel specifically, I'm talking about Jerusalem. So that's why, and you see a lot of religious people from all sides. So these people, there's no other place in the world will satisfy their needs or spiritual needs apart from or except Jerusalem or Nazareth, or that one thing. The other part, every person over there involved in politics. When I was there, I was involved in politics because that's part of your life.
Right.
One of the things, I have friends from Rambam Medical Center. First thing, I came to Australia after a year. I went there and I went and visited them. Jews and Arabs. We worked together, we studied together, and some of them doctors or researchers in the hospital. I remember first thing, one of the guys asking me, "Where are you, Naz, these days? We don't see you." He didn't know that I left Israel and I came here. I came to Australia. And I said to him, "I'm in Australia." He goes, "It's boring." And that's an immediate action.
Yeah.
And I was looking at him, but everybody understood why. And what he meant, you don't hear airplanes every day. You don't hear bombs. You don't hear explosives or you don't see explosives in buses. At that time was during the Intifada.
Right.
So because of that, so everybody involved in a war zone, and everybody looking for to survive. Now, either to survive by telling the narratives that he or she believes in, and then you're talking about straight away a conflict that been there for thousands of years and intensified in the last 76 years after the creation of Israel as a state. And now we're talking about two nations, talking about the Palestinians and the Jews, where they are same numbers. We're talking about almost 7 million people of each living between Israel, West Bank, and Gaza. So pretty much everybody is part of that conflict.
Right.
When you're part of that conflict, obviously, and you don't have other choices, you cannot go and live somewhere else. You don't have another nationality, so you're looking for survival. You're looking for, I have to prevail. I have to be the the winner of this. So that's why immediately you start to become very patriotic about the place, because you develop these narratives based on that feeling. So it doesn't matter if you see a Jew, you see a Muslim, or you see a Christian, or a Druze, or a Bedouin from Israel, born there, live there, and you see them in Europe or North America or in Israel or in Australia, they're going to tell you this story. Right? And now they're talking about it a lot. And a lot of people, for example, who after the war started like 9 months ago, if they have dual citizenship, they left Israel. And there's about 500,000 Israelis, they left there. But the rest, because they had choice to go and live somewhere else, at least until the war is over.
Yeah.
But my daughter, she was living there with her husband. But because she has an Australian nationality, she had to come here to protect herself and her son or her husband.
Yeah.
But eventually, when war settles, they most likely they will go back because their work is there. But again, to summarize all that patriotism based on what they're experiencing, and because they have no other choice, and everybody has to prove that he or she the right, or their story is the relevant story.
Yeah, well, you made an interesting point before about, if they leave, it's like they don't have the security that we have here in Australia. If we leave, no one's going to take our house. So it feels, the way you've described it to me is that, whether you're a Jewish or Muslim or Christian, you almost have to stay behind to maintain your own people's right or the religious right to that area. Is that sort of how it is? Yeah, good way to characterize it.
Even if they're not religious.
Right.
If they're religious, it's more for them.
Sure.
If they're not religious, they have no other choice. If they leave, like that what happened to the Palestinians in 1948, when they left because they thought, well, things will settle down, and they went to refugee camps in Lebanon or went to Europe or other places. Till today, they have the keys of their houses, but they don't have the right of return, what we call it, and we hear this a lot these days in media. So they don't want to experience this again. And the Jews, they have the same feeling. If they leave, and let's say the Palestinians occupy or they take the land back, as all we hear these days, that's some of what happened in Gaza and all that. So that means the other person will lose the house, will lose the place, and where they're going to go? They don't have other place. So that's why we're saying these days, I personally say, best solution is to have one country for everyone there, and to live like the way we live in Australia.
Yep.
So all will be, and that will be a real democratic country, because everybody has equal parts, equal obligations, and equal responsibilities, and equal rights. And by doing that, you won't have that fear again anymore.
Yep.
And become another big, safe country for everyone.
Yep.
But these days, everybody's trying, no, it's mine. When we fight about something, somebody has to lose, some other person has to win.
Yeah.
So the loser, basically, going to lose their place. They're going to lose the ability to do things that what they're doing at the moment. And that's why it's a natural response for every person living that place to be patriotic and to fight for that thing.
Right.
So I don't expect, and some people, they utilize that for their own personal things.
Right.
So a lot of politicians, they do that.
Yep.
And we experience these things these days, or people who have who fanatic about their religion, doesn't matter which part they come from.
Yep.
Because over these things there is no reconciliation. If you and I have different opinions about, let's say, you advocate for capitalism and I'm advocate for socialism, for example, we can sit around the table and to come to an agreement and to meet in the middle. But when it comes to religion and comes to personal interest, no one will compromise, and that's why we see. Because I never seen like fanatic religious people from different parties come to a conclusion and to agreement about something for thousands and thousands of years. And when you have this factor involved, I don't think will be a peaceful solution if they are in control.
Right.
That's why religion has to be, very personal. And when it comes to running a country and politics and all that,
Yep.
My opinion, seculars, they will control that better.
The secular model is
It's more appropriate.
Yeah. Okay.
More appropriate. And
Interesting.
because they will have an understanding, and we will have law and rules to govern everyone. Doesn't matter what religious background, doesn't matter what national background. Again, like Australia, we have all the religious, all the different religions.
Yep.
We have all sort of different, but we have one law for everyone, and that what govern.
Do you also look to places like Singapore, for example, as another model that might be able to work? I think it was Lee Kuan Yew, united a whole bunch of different ethnicities and language groups and that sort of thing under one sort of banner.
Yeah. And look what they are now.
That's right. They're
number one in the world.
They're amazing place with
what I mean?
no natural resources.
Exactly.
Yeah.
And because then you will have the moral high for everyone, the productivity, because there is security, there is sustainability. In Israel, there's no sustainability now for everyone. That's why I'm here. That's why I was looking for a place, not just to do my PhD and to become a scientist, but also to look for a place where I can be safe for my kids.
Which is what everyone wants.
Exactly.
Yeah.
Safety for your family is the first thing you look for.
Yeah.
I mean, unless if you don't have other choice, you have to go and, but why to fight and kill each other when we can live together peacefully? And in Australia, we do that. In Singapore, they do that. In a lot of countries around the world, they do that. In a lot of places, they do that. Yeah. But certain places, fanatism is too extreme.
Right.
That there is no place for negotiations. And that's exactly what's happening now over there. If you look at both parties, they're fighting. They're controlled both by very religious people.
Yeah, at the sort of polar extremes of,
Yeah.
Do you have hope that this conflict will come to some sort of...
Always you have to have hope.
Yeah. And what, I guess, added to that question, what was the closest in your mind that we've come to peace in that sort of area? What?
Look, the world now realizes exactly what's happening. A lot of people before this war didn't know a lot of truth.
Right.
Didn't know a lot of facts. Now, the new generation, they start looking at it differently from the old generation.
Okay.
The new generation, they understand the narrative very much better than the old generation. This new generation, we're talking about university students who is going to control this world in 10, 20 years' time. They're the politicians, they are the scientists, they are the economists, they are the people who are going to control that. So Palestinians and Israelis, it's hard to get to an agreement after all what happened. The hatred is there now. A lot of bad things happened, and We can see, it's based, all what happened there is based on revenge, not the rational there. There's no rational behind it.
Mm-hmm.
So that's why I have hope. I have hope because the whole world will end up saying, enough, it's enough.
Mm-hmm.
And it's not up to you guys to continue like that.
Yeah.
Because it's a destruction for the whole world, to the humanity, to the morals, everywhere, for everyone. I don't think anyone wants his kids to watch TV these days, to watch the news, to see the horror that we're experiencing there. So this will be ended when the whole world intervene in a way to find a real solution, not a temporary solution or to satisfy certain needs for certain parties,
Right.
which been all the time the way.
Yeah.
And that's why they didn't reach any solution. And to be controlled collectively by the whole world, not just by one country, that they have again certain interests, either economically or politically or so eventually they will get to this resolution or to this conclusion because it starts affecting everyone. You know, people were looking at, maybe other countries are going to get involved in war now and lead to a third world war. When that happens, no one will be safe. Even here in Australia, we won't be safe.
Yep.
Well, at least we start seeing sometimes kind of aggression in the street in Melbourne and Sydney, big cities.
Yep.
Host everyone. So, and that's why, again, hope is associated also with actions, and actions, proper actions, we will be there.
Well, hopefully it's sooner rather than later.
Yeah.
I didn't get you on here to speak about the conflict over there, but I really appreciate your honesty and your perspective, because you're someone that's got that actual lived experience. Like you, that's your homeland. And I think a lot of people don't have, such as myself, don't have that real insight into what's actually going on over there. All we have is what we see on Twitter or Facebook or those sorts of poisonous kind of channels. So yeah, thank you for that.
No problem. Thank you.
We'll move on to your research now. That's why we that's why we got you here, Doctor. So appreciate that. This technology that I've seen you've been reported in the NT Independent, the NT News. I think you mentioned off camera ABC earlier. This hydrogel ball technology.
Mm-hmm.
What is hydrogel ball technology? How did you get into it? Can you give us a bit of an insight into that?
Yeah, that's a very interesting topic, but very, very far from what we've been talking about.
Yes, it is. Hopefully a bit more uplifting and positive.
But probably all we're talking about getting things together.
Right.
Now, if you look at drugs in general, drug is an active ingredient. To make it a medicine, it's what we use. Like if you take paracetamol, it's a drug.
Right.
The medicine is Panamax. What does that mean? It's a tablet which has 500 milligrams of paracetamol, but the actual tablet will be much more than that because it has binders, has different ingredients to give different taste, to give color, to have the shape, and to protect it from, sometimes we have coating to protect from humidity. All these things together, what we call it excipients in drugs. This is a drug delivery system.
Right.
So the drug is one part from the medicine. Now, when you look at the medicine or the drug itself, you need two things from it. You need to have it safe. So you don't want to have it toxic.
Yep.
That can kill good cells.
Yeah. Side effects and things.
Side effects and all that.
Yep.
So you need to minimize side effects. But minimizing side effects sometimes requires from you to minimize the amount of the drug in that tablet form. And that reduces efficacy. So two critical things, and that's the first thing when I give my students, when I talk about drug delivery systems, I present this kind of cartoon thing where is two things like pulling apart, one of them the efficacy and one of them the side effects. To bring them together and to the middle of the conflict, if you like, is by producing a unique delivery system that can allow you to take the minimal amount of the drug to minimize side effects, but to be effective at the same time.
Right.
And that's when we talk about any delivery system.
Sure.
Now, if you look at this hydrogel, and we'll come to the what does it mean hydrogel, it's been produced to produce what we call it biopharmaceuticals. Today, we have the area of biologics, what we call it, or natural products that mimics exactly what happened in our system to solve our problems with diseases. Give you an example. When I say biologics, I say proteins, active protein or active peptide, like insulin. Insulin, it's a small peptide. It's about close to 49 amino acids attached together. Now, these proteins and these peptides, they're the optimal to cure our diseases. Because if you look at cancer, sometimes it's a defect in a gene or missing a gene or mutated gene that gives you wrong protein. The proteins in our cells, they produce signals to cure the cell, or if the cell time to die, to kill the cell and or to produce another cell or to help other cells.
Yep.
So instead of having what we call it a synthetic molecules that we have that has a lot of side effects, I call it dirty molecules, because it doesn't just help you to sleep, it gives you dry mouth, for example,
right,
and gives you problem with the bowels, etc., etc.
Yep.
So to get away from synthetic stuff, we need to go and mimic these proteins and peptides, and that's what we call in biologics,
Yep.
or biosimilars, when we start producing similar to them.
But when you, sorry, just quickly, just when you say synthetic and then it's the difference between what you're just referred to, can you just explain the differences between something synthetic, where the origins of that synthetic?
Well, synthetic,
thing
you're
is?
you're taking atoms, like you're taking nitrogen, hydrogen, carbon, and you put them together,
right,
to make paracetamol.
Mm-hmm.
And that paracetamol, that's a synthetic material, so you produce it in the lab.
Yep.
Okay?
Yes.
It's not, the nature didn't produce that for you.
Right.
You produce it. The nature produced these atoms. You put these atoms together,
Yep.
to make a molecule that it fits the, what we call it, the receptor where it's going to work. It's like a key and a lock.
Mm-hmm.
And that activate the cell to do what needs to do, or to stop things, or to produce new things. But this synthetic, it can fit more than one lock in the system. That's why you get something for antipsychotic, for example, and you see it works on the stomach as well, or causes diarrhea.
Yep.
We don't want this.
Okay.
And that's a problem with synthetic molecules. It has a lot of side effects. There's no specificity.
Right.
It is efficacy, but even the efficacy. So that's been all the time. So more than 98 of our medicines based on synthetic molecules. And we're trying to steer to get away from that by producing what our system produces, either in antibiotic form or certain proteins. Because if you look at the cell, we have about 700,000 different proteins, active proteins in our system. We're expecting to be another also 300,000, close to 1 million different proteins.
Wow.
The cell every day experience close to 1 million mistakes. These proteins get signals from different proteins inside the cell to go and fix something. Go and fix this, go and fix that. And if you don't fix it, that's why we said don't overload yourself with food or with sugars and things like that, so you can give some free time for the cell to go and fix itself, and that will prevent cancer. So every day, every cell experiences cancer episode.
Wow.
But it's fixed because of these proteins, and that's what we're working on.
Okay.
And that's why you see these days the most successful medicines in when you give these proteins or biologics to treat cancers or to treat, again, diabetes or to treat all sort of different things, or arthritis. So, but problem with these biologics, very sensitive and bigger molecules.
Right.
When you take it, if you take it oral, so that restrict these molecules to injections rather than taken in capsule form or drops or things like that, because they are very sensitive to stomach acidity. So easily can get
Like broken
deformed.
down. Yep.
Yeah, broke down.
Sure.
And also they're very sensitive to temperature. That's why we don't want our body to have more than 38 degrees, because then we will have all these proteins in our system out of order and the biological system will die. So these two major issues, that's why we have so much research happening on these proteins, but till today we have less than 300 molecules. They say they're more than that, roughly around 300 molecules, proteins to treat, but some of these molecules are very expensive. Some of them can go up to $10,000 a month. Injections that we give it for arthritis, it can go to $1,000 or $1,500 a month, and it's very expensive compared to the synthetic molecules. That's why we're looking for ways to have it more popular, to have it to be taken not just injectable form, which also makes it very expensive. And the other thing makes it very, very expensive, it's the logistic handling of it, because it has to go through cold chain. Now, as a pharmacist, I'm practicing pharmacist as well. When I do make an order in the pharmacy, always comes a note at the end, if I order any of these biologics, that you order a fridge item, and that means you cannot return it if it's wrong. So every pharmacy you go to, you will find at least one or two items ordered by mistake and could be thousands and $10,000s of dollars sitting in the fridge, waiting for a new prescription to come in because you cannot return it, because it costs so much money and so much time for the drug company, for the producer, for the pharmacist, for the everything, and even like, you cannot travel with it. So it's a very complex process. These two problems, the acidity problem being solved before through coating, but the thermosensitivity, the sensitivity to high temperature, still a major problem. That's why one of the reasons that's why they don't produce many of these, because it costs a lot, and it's not going to be profitable for the company if they want to invest in that, and not many people are going to use it.
Yep.
Now, having said that, the market today for biologics, it's close to $280 billion. In 2030, we're expecting that to be close to $900 billion.
Jeez.
So there is a lot of increase, but we're still having an issue to have, again, the vaccine, for example, instead of going to the doctors twice to get a script and to go back or to go to the pharmacist, and when they give you an injection, they will charge Medicare. So if we give 12 million flu vax a year in Australia, multiply that by extra $40 and that Medicare money. We're talking about billions of dollars.
Right.
To solve this problem, we came up with this technology. We created this hydrogel. Now, what's hydrogel? Hydrogel is an organic product, like, for example, cellulose, which is a solid material, mixed with fluid. And if that fluid is water, we call it hydro. So it's become a gel. You mix fluid with solid material, a certain size that solid material has to be, what we call it colloidal material, which is between around, let's say, 500 nanometer, the molecule. You create a gel, like a gel you create in the food industry.
Yep. Agar and that sort
Agar and all that. It's all the same principle.
Right.
But the hydrogel, it has unique characteristics when it comes to biophysics, when it comes to chemical and physical characteristics. And one of these characteristics, it's an interesting one, that we know it in different industry. In food industry, we're familiar with it. Pharmaceutical industry didn't go into that much because it's the complexity of it. It's very complex. And what's this property? If you look at the solid material, just before I go there, if you look at solid material, if I look at, let's say, a disk or table,
Yep.
and you look at glass, both solids. If you put the disk out in the sun and under the rain, will crumble. If you bought a glass 100 years under the rain, you come back and you see it still the same.
Mm-hmm.
So why is that? It's both solids, but they are different solids.
Mm-hmm. Different physical characteristics.
Different physical characteristics. One of the physical characteristics, if you look at the disk, there is inside it around 30% space between the constituents of that disk. There is about what we call it free volume.
Right.
So a space which is free, 30%. If you look at the glass, you have just less than 3% free volume.
Right.
What does that mean? That space allows the actual molecules of the constituents of the disk to interact with each other, or to interact with water, or to interact with humidity. And that's what makes it crumble very quickly and becomes what we call it out of date. Where a glass, it doesn't have this. It has more robust solidness in it. So the question was, can you make a tablet in a glass form, not in a disk form?
That's an interesting way of putting it.
And that's what I did.
Wow.
So, and why is that? If you look, to complete the picture, if you take a steak out of the fridge and put it on the bench top, it would take a couple of hours probably in Darwin's heat, and they will go off.
Yep.
You start smelling that. And what you're smelling, the evaporated molecules from it, the sulfur and everything that start to evaporate.
Yep.
Why is that? Because you gave the steak a free volume around to interact with everything. Whereas when you put it in the fridge, you shrank it.
Right.
Because of the temperature. Temperature expands things.
Yep.
And if it's low temperature, shrinks things. You shrank it. That's why it doesn't go off. So if you take a tablet and you put that protein or the biological treatment for cancer or the vaccine into that glassy tablet, you will restrict that tablet, you restrict that vaccines or the molecule of the protein, which is very similar to the steak we have. Mm-hmm. You restrict that from movement, from vibration, what we call it. And that will restrict the interaction with the surrounding environment, including everything around it. And that's what keeps it. It's like you replace the fridge and replaced the low temperature by having a very restricted vacuum or space for these molecules to interact with the surrounding.
Wow.
And if you manage to do that, you basically solved this thermal sensitivity problem.
Okay.
And if that glassy thing also resistant to the acidity, you basically solve two problems in one delivery system. And you made a medicine from a drug. And that's what we done. We took that hydrogel and chemically we worked on it to make it glassy. So how we make it glassy, there is two types of chemicals in the world. There's something we call it crystal and something called amorphous. Crystal is when it's like a diamond, which is arranged together nicely, like sugar. When you take amorphous is when you cool it down to the freezing point and you don't allow these molecules to arrange itself like a diamond next to each other, so it becomes random. That random pattern leads to physical characteristics. I'm not going to go through this now because it's too much mathematics and physics there.
Right.
But gives you a glassy state.
So that's what you want instead of the crystalline
join
or
So basically, we worked chemistry-wise to produce certain physical characteristics to the material to transfer it to a amorphous form that enters a glassy state.
Right.
And that glassy state, you can resolve it, you can pack things on it, and you can resolve it by heating it up above 50 degrees or by introducing water for hydrolysis in the intestine.
Okay.
So when you take it, you don't need to heat it. Basically, it will interact with the water in the intestine, which does the same thing because it breaks chemical bonds.
Yes.
Hydrolysis.
Okay.
And that when you release your material to the intestine and the blood vessels start absorbing it and take it to the system.
Right.
So basically what we've done, to summarize it, we took a material from semi-synthetic glucose or sugar. Mm-hmm. We call it hydroxypropyl methyl cellulose or HPMC. Mm-hmm. We reacted that with another material, we call it acrylic acid, to give the acidity moiety to it a little bit so that will prevent its interaction in the acidic, in the stomach acidity.
Yep.
And that will interact just with alkaline, what we call it, which is the right area or the right environment in the intestine. So by doing that, which is both very cheap, very, as in price, very, very, very low price and abundant in nature, this semi-synthetic glucose you can make, it's everywhere.
So that means it's going to be more accessible to more people.
More accessible, very, very cheap. All what you need to have the right way of mass production and to incorporate into your vaccine or your biological treatment for cancer or for vaccination or for anything. So you will solve the cold chain problem so that will reduce the price, will reduce all expenses related to Medicare and all that thing.
Yeah.
So you get free more, abilities Medicare to produce more stuff.
Yeah.
For patients and for pharmacists and for doctors and for everyone and for scientists to work on other things. And also you protect environment because imagine all these. You have no idea, like the amount of syringes and needles that we use for these injections, and we have to go and incinerate it afterwards. And we're talking about climate protection and all. So that's another area which will be benefited from this technology. So that's basically what we've done. Hopefully, I don't know if I managed to deliver the, to translate the chemistry and the physics into it to simple terms. Yep. So average person will understand. Look, it's in the lab. It's something very complex, and even when I give a presentation about this to scientists to explain it and to explain the mathematics and the physics behind it, it's very complex. And if scientists, if they're not in the field, will find it very hard to understand what I'm talking about. Sure. But that's what I'm saying. It's very difficult sometimes to even make it more simpler and to put it in a simple terms for average person to be able to understand what we're talking about.
I think I understood, and I just want to say I can tell that you've taught before because you were able to explain it to someone like me who doesn't understand anything about pharmacy or really chemistry and that mathematics, that sort of thing. Maybe if I could describe it to you how I understand it, and you can see if I'm sort of got the right idea. So basically, you put the medicine that's going to help someone's ailment into a tablet with this hydrogel coating. It doesn't break down within the stomach. It's got some sort of chemical property that can fight off the acid. Then moves to the intestine, where the water in the intestine is the condition you're looking for to actually break it down. Exactly. And then it's delivered into the body the right way. So I think it sounds revolutionary, really. And
the theory that we based all our work on is the free volume theory, what we call it. Okay. Where we minimized by having this hydrogel rearranged chemically and physically. Yep. By a super, what we call it, cooling system to the level that reduces the free volume inside between the molecules inside the hydrogel from 30% to 3%, and that will prevent any molecule you put it into it to vibrate and interact with the surroundings. So that's what replaced the fridge or the low temperature.
Yep.
So the free volume reduced, and that basically, by doing that, you don't need to refrigerate.
Yeah, wow. So you can take it to any sort of place just about on the
just
planet.
normal delivery.
Put it in the cupboard.
Yeah, and put it on the shelves in a pharmacy until the shelf life is over.
So how far along are you to bringing this type of technology to market? I understand you were registering a patent.
It has been registered. It's already patented, and it's already protected by a U.S. patent, international patent. And it's sitting there for an investor or a pharmaceutical company to come and say, well, let's complete the preclinical studies. And if I would say if there is an interest in that between 3 to 5 years, such technology, without rushing it.
Yep.
We're not talking about an endemic or epidemic at the moment that will force us to rush it.
Was it Project Lightspeed or whatever it was in America?
So, but if we need to rush it, probably in a year time will be out there. But if you take like a normal process, and to have the clinical trials done effectively, it takes between 3 to 5 years.
Okay.
But that will be, as you describe it, also a revolutionary thing, that you will be able to take less expensive drugs, which is very expensive at the moment, in a very handy way, and in a preferred route of administration.
Yep.
Like we're talking about taking orally rather than taking an injection that requires refrigeration, requires professionals to administer it, requires all sorts of different, and sometimes people hate taking that.
Yeah.
Like I know a lot of people, they don't want even to take insulin because they have to inject it.
And there's religious reasons some people
And there's a
don't,
lot of religious people, there are religious issues behind it. Now, by the way, this one also we looked at how to have it halal and kosher. So no other things involved in it.
Yep.
We're talking about cellulose, which is a natural product. You find it on leaves and branches, trees branches and all that.
Amazing. Yeah. So you get to you've registered the patent, so you own that. Is that right?
It was between the team or myself as a main inventor and RMIT.
Okay.
So RMIT University, they the deal is 50-50.
Yep.
But I have to give RMIT the rights because they're conducting the registration. They basically, university spend the money for registration and costs lots of money from provisional patent to take it to US patent. It takes time. Also supported me with a grant, so I conducted further studies into that to optimize it through my postdoc time. So RMIT is taking care of it at the moment, but it's registered as as the owner. However, as an inventor, we are involved in that as well, but in different level.
Yeah. So do you mind I don't know if it's a quick process or it's easy to summarize, the patent application process? Is that a drawn out process?
Yeah, it's when I started this, I knew where I'm going to take this from day one, because one reason, I'm a health professional and I know what's missing in the market. That's why I encourage a lot of pharmacy students and medical students always to go to research if they can, because they're the right people that they can drive this industry very well.
Right.
Biologists, also I'm a biologist originally. As a biologist, when I did my master's degree, it took me a while to understand what I'm doing, because you don't see, in the old days, we used to have this classic science where a scientist produce something, put it in the shelf, until the intellectual comes and take that product and present it to the industry. These days, we have in Europe by itself, more than 240 universities. We call it applied sciences universities, like RMIT University, for example, where the scientist takes things from A to Z, where you take it from the theory to the final product in the market. So if you are a health professional, you always have the ability to identify what's missing and what you're looking for, so make it much easier for you to understand where you're taking product.
Yep.
So when I started, I knew what I wanted, and I worked on that. So that's why it didn't take me much for me to get into that stage. But once I got it, I went to we presented that to RMIT University. We said, well, there is a potential patent here because this can be commercially very viable. They looked at it, and they came back with a positive answer. But on that positive answer, that means there's a potential for patenting, and then everything starts. So over 7 months, the lawyer they appointed, there's special lawyers for this, and always lawyers for patenting, they are scientists too. So the lawyer who took care of this patent, she has PhD in chemistry. So when I was talking to her, she was understanding exactly what I'm talking about. And when she was coming back to me, she came back to me the first week, she came back to me with 4 different projects. One from Japan, another one from Europe somewhere, and 2 from Asia that has similar technologies.
Right.
But there's fundamental
Differences, yeah.
And I had to answer that.
Okay.
So I was kind of interrogated for 7 months.
Scrutinized and...
They go through Google Scholar.
Are you copying anyone, that sort of thing?
They go and check every single point in the world being produced, and they come back to you. I reach a stage that I start giving answers that we don't know if it's a right answer or wrong answer because the question has never been asked before. The answer hasn't been even seeked before. Right. So because we're trying to answer, like she's coming to me and, okay, when you patent something, you have to patent it in a way to have it strong. And how they do it, they do claims. Like you in your patent, well, in this patent, the provisional patent has about 23 different claims. So, for example...
Is that claims you're making?
Yes.
Yes, okay.
So what does that mean? The claim I make there, like if you produce this hydrogel within in a certain ratio, if you go below that ratio, to what degree you can go below that ratio, and above that ratio, that's still viable as a delivery system and safe, to prevent somebody else coming and claim that ratio and do some similar thing, because they can't do that.
Sure.
So you have to answer which degree. So you have to go back to the lab and do some research and do some work. And sometimes you don't know really, or you cannot do it sometimes, but you assume based on theories, based on things done before.
Right.
So this patent has about 23 different claims to have it strong enough to prevent anybody else from coming and saying, I can do something by changing these things, and that will change the product, but I will come up with the same result. And they can list it. So to prevent that. So that's to that degree, you have to be so careful, and you become the expert, the most expert in the world when it comes to this. Because basically, you argue your case against every single research being published. And you're talking about millions of publications every year. So you have to defend your invention against any close enough project being done before.
Right.
And you've got all these different questions. So that's the first, after you exhausting, or the lawyer or the legal team exhausting all these avenues, they take it to, and what we call it, a provisional patent. Normally, from patents around Australian University, for example, I think less than 15% from where you start this process as answering questions to the final go through the provisional patent. Okay. Less than 15%.
Yeah.
So if you get to that level, they give you 12 to 18 months to do further studies to strengthen it. And that's what happened. And after that, they look at it again, with another legal team, and they look at it. Is it because each time it might cost up to $200,000 to list it? So they go, is it good enough? Is it valuable enough to take it to international patent? So what they did, after 12 months, they took it to what we call it PCT, which is Patent Collaboration Treaty, and that's based in Spain. And that becomes kind of international, so internationally will be visible.
Yep.
People, if they have anything against it, they can come forward if they want to revoke it or do something, and gives you more protection. Mm-hmm. After that, 18 months after the PCT, they decide to take it to, they come to you and say, Naz, and that's why they came back to me after 18 months, and during that process where I produce more studies, and always under questions and all that, they came, okay, now we think it is strong enough and worthwhile listing it as an world patent, which, and world patent, there is the US patent, which is the strongest one, there's a European patent, and there's a Chinese patent, and there's something called also world patent as a world patent, mm-hmm. I think in Munich, their base. So they ask you which jurisdiction where you want to be. What's your recommendation? And I sent them an email at that time recommending US patent, because if you look at biologics and big pharma companies they deal with, is like Pfizer, for example, one of them. Yep. They are all American. So they have access and they feel more comfortable to handle this legally. Mm-hmm. So if they want to go through, so they go to the patent, which is already under the US law. So it will be, and they deal with the US law themselves as well. So it will be very easy. It's kind of, it's on their box. Yeah. And the exposure, they trust it, et cetera, et cetera. Yeah. So make it easy for them. And based on that, I suggested that thing, and RMIT accepted it and listed it and applied for it, and it's been approved.
Great.
In 24th of Jan.
Wow. So in the US getting a patent, what then is it the FDA? The
FDA, so now...
What sort of interaction do they have with this process?
All right. Now, the FDA, they don't get involved until the pharmaceutical company comes up with the final results of their clinical trials, they supply or submit their application to take this product or this technology to produce their medicines in it. Mm. So what they need to do, they need to show the safety and the efficacy and the viability to the FDA. So they pay their fees. And obviously, after they have the deal happening with RMIT University, and then the FDA start to get involved, and also the Therapeutic Good Administration in Australia, the TGA, if we want this to happen in the Australian market. Right. Yeah. But the TGA is separate from the FDA. It has very high standards. It's higher even than the FDA. So even if we have medicines that have been in the market for 10 years sometimes in Europe and in America, when we get it here in Australia, we still have to do our own 3 phases clinical trials, which takes between 3 to 5 years to get it approved through TGA. So we have to do that. The pharmaceutical company that bring it back here, they have to do the process again and to pay the new fees again for TGA to have the medicine approved. That's why we have a lot of medicines around the world that we don't have it in Australia, because of this process.
And does that then mean that medicines can become more expensive in Australia?
Becomes more valuable worldwide. And even some companies or some pharmacies or some pharmaceutical distributors, they start asking, we want the TGA, one of them.
Wow, because it's the most stringent.
Yeah. I had experience where in my previous company, we used to import what we call it butterfly catheters. Okay. And that was it's produced by an American company. And many times we had these surgeons coming to us, to AIMS, Australian International Medical Supplies in Melbourne. And once I picked up the phone, I asked, that's strange, because you've got this product in America. He goes, no, we want the Australian list because they are more more strict about certain properties that we're looking for.
Right.
And they prefer to have the same product, American product, from an Australian company and from Australian distribution, rather than having it from American distribution because of our high standards of TGA.
Wow. It's fascinating side of things that I just never could ever grasp. It seems very complicated as well.
It is.
Yeah.
It is.
And then
costly.
Once you've got the patent approved, how long is that then in your ownership? Is there a time limit?
There is time limit. Depends on can go up to 15 years, sometimes 30 years.
Yep.
Depends on the product. Depends on sometimes 7 years.
Yeah. And then does it lapse and what?
And then either you need to renew it or somebody else can get into that. Depends on the conditions of that patent.
Okay.
Yeah.
You're doing some other work with cannabis extracts, is that right?
Yep.
Can you explain a little bit about that?
Well, cannabis, this is, remember how we said, like, we're trying to mimic what happened in our system. Now, we have proteins that we're trying to give externally, like the insulin again. But we have what we have in our system, what we call it endocannabinoid system. It's like we have the central nervous system. We have endocannabinoid system, which is based on receptors, what we call it CB1 and CB2, some of them in the lymphatic system or in other organs, and some of them in the brain. And we have the actual cannabinoid that's secreted from the endocannabinoid system that gives us ability to fight certain diseases or boost our immune system or help us against nausea and vomiting or help us to reduce pain. Mm-hmm. This is discovered in about, actually the father of cannabinoids is Professor Raphael from the Hebrew University from Jerusalem. And he discovered that in the 60s. He just passed away about 7-8 months ago, aged 93.
Wow.
So he's the father of cannabinoids. And in the 80s, a lot of companies, or researchers, especially in Israel, they start looking at this. These days, we have it very strong in Italy, in a few European countries, in Brazil, and also in Australia. So what we're trying to do, we're trying to understand what in cannabis, either from the root of that cannabis or the leaves or the flower, and what products we can put them together to have them effective against certain stuff. Mm-hmm. Now, there is something unique about cannabinoid products, and we have so far identified close to 150, what we call it phytocannabinoids, which is different ingredients, including phenols and parabens from the actual cannabis, that synergistically they work together fantastically. What we call it the entourage effect, where we have a complex, not just one ingredient of a cannabinoid, mixed together, have an effect on growth of cells or on memory or in Parkinsonism or in dementia or in endometriosis, mm-hmm. and.
Wow.
One of the areas growing very big, cancer. And we have a lot of work being done. And I have also people who came to me and they used
Do you mean
cannabis.
Cancer is more people are getting cancer or there's more research?
More research.
Okay.
More research getting on cannabinoids and the effect of cancer on cancer cells.
Yep.
And we know that a lot of people used cannabinoids to reduce symptoms or to cure cancer. It worked for them.
Sure.
And I know cases myself about cases like that. And recently I've been approached by a group of, or by a charity who, based on their experience, and they support cannabis in cancer research.
Interesting.
So what we've done, there is a startup pharmaceutical company, a UK-based, but also I think they have an office in Perth and now in Slovenia. They produced a mixture or an extract which has CBD in it, mm-hmm. and few other ingredients, extracted from cannabis.
Yep.
sativa, and they called it FIC66. We tried this, and we found it has a very obvious effect. We managed to prove, and even to get to the mechanism of action, how it works inside the cell and what signals it gives to the cell itself to turn it to start what we call it apoptosis process. Now, what's that apoptosis? Every cell in our system, let's not talk about central nervous system, okay. But other cells, like let's say, for example, blood cells.
Yep.
They every 28 days these cells has to it dies and new cells coming replaced.
Replenished. Yep.
Yeah.
Yep.
And certain cells, when it has a defect in it, when it start, like we talked about, how many mistakes happen in cell every day. So I saw there was a protein called P53. Protein P53 identify if there is a damage in a DNA of that cells, okay, and repair it. And if it doesn't repair, give signal to another peptide to go and kill the cell. And that will prevent cancer. Now, sometimes these cells evade these kind of signals. And cancer cells basically becomes a problem for the body. Why? Because they just consume energy and consume the food and things that we give. That's why people lose weight when they get cancer.
Right.
And they just grow without any kind of regulation and becomes useless. So the only way is to reverse them back to the process, which is what we call it a self-killing process, or apoptosis, or organized death process for the cell. And that's what happened when we tried the FIC66 extract from sativa, and that's what we noticed in melanoma cells, virulent, as in very deadly. Right. Melanoma cells, and basically we managed to get to the level where we knew what happened inside the cell and how accumulation of what we call it reactive species inside the cell lead to toxicity level and killing the cell at the end of the day. So we managed to do that through lab technique and chemical markers, but also we looked at it and we could see the fragmentation of the cell under the electron microscopy. Wow. So we could see that, and we could also get the markers from chemical tests that we've done.
So how exciting is this work? What sort of applications do you see it having? How far can something like this go? It must, when you see cancer cells dying, that's, I guess, always a good thing. Yep. But sort of how far along do we need to go before this can?
That's a very good question. Now, when you take, there is two type of trials we do in research. What we call it in vitro and in vivo. There is in situ, which is when we use simulation, computer stuff, things like that. Right. We use this a lot in pharmaceutical sciences and in pharmacology these days. But also the main one, it's in vitro, which is the first, and it's a lab conditions. And it's exactly what happened, what we've done. Right. We take these cell cultures, what we call them, we grow them in an incubator, and we start adding the active ingredients, or we start doing all these tests on these cells. Yep. But cells are different from the whole body. Whole body is calling in vivo. But we're trying these days we're trying to utilize the 3D technologies in cells to have not just 2D technology where you have the cell culture just one layer. We can mimic exactly what happened in the actual tissue by having the 3D cell culturing. But that's still not enough. So once you finish the in vitro studies in the lab, the next stage will be in vivo, and that's where we start looking at animal studies. And we are in a stage that we're looking for money, for research money, to take this further by having it tested in animals. Rats, we use rabbits, we use pigs, we use a lot of different, depends on the model, depends on the actual thing we are investigating.
Yep.
But also, during this time, we're also trying to figure out what type of delivery system we need. And we go back to the hydrogel. So are we going to take this subcutaneously, close to the melanoma cells? We can make what we call it self-healing hydrogel, which is a rubbery hydrogel. We can inject it. It's like a liquid, but once you inject it around the melanoma cells, forms like a reservoir, like a gel that form there for 2 weeks, 3 weeks, depends how long you want it, depends on the ingredients, what you put in it, and that's another delivery system. Or we want it orally, for example. Let's say we need to treat cancer cells in the intestine. Or are we going to keep it an injectable one? There's so many different ways. It depends on the application, depends on the indication. What's the medical condition and how you want to treat it, and what's the acceptance of the patient to take that. So this delivery system happen in parallel probably when we do clinical trials, if we want to do it, or other team might do it. Or sometimes you don't have to do it. We're talking about it because we are involved in both areas. But sometimes, scientists can take this to inject it for rats or rabbits. And then when the pharmaceutical company want to take it to clinical trials, they start thinking, how are we going to produce that? All right? And then either we'll do that through the R&D in their at their base, or scientists academics, they might work on this. Depends who is taking care of that.
Okay.
So to answer that question, now it must go to what we call it animal trials before it even goes to clinical trials.
Right.
So to do that, obviously we need some money to come through. And a PhD student. We have a postdoc and a PhD student lined up for this, that we can take it further later on.
Right. You mentioned earlier the father of this type of research commenced or discovered something in the 60s, was it?
Yeah. When he started thinking about, and when he put the first time the concept being put out there, that cannabis can be a potential to cure disease because we have similar thing in our system. Was in the 60s.
That's really interesting. I've got a couple of questions out of that. I think I'll ask the second one in a little bit, but does that, in your mind, seem like a relatively late start to that type of thinking? Like, was there a stigma around cannabis at that time? I've heard, I don't know if it's a conspiracy theory, but the hemp industry was a threat to the rope industry. So the Americans or the British, I can't remember what it was, shut down the hemp industry because,
This is a very interesting question. And not just in the 60s, even today, when you talk about, I was interviewed in Israel. And that was first question asked. And the interviewer actually had to explain at the beginning that to the listeners, don't think that smoking cannabis the same like what we're talking about today. And especially, and we have to admit it, Israel is a religious country. Till today, the debate on the deregulation of cannabis, it's very, very strong in Israel because the Jewish Orthodox, they have a lot of control on a lot of avenues in the government and the health department, everywhere. So, and that's in many other countres in the world.
Is that the Haredi or?
Haredim.
Yeah,
the Haredim.
Haredim.
So, and actually I remember last year, the health minister was one of them. So that's why this topic didn't take much augmentation, let's put it that way, or not much work being put in there, and not just in Israel, and many other countries.
If you debate.
Look, if you take the Middle Eastern countries, no one Arab country I come across that they work on this in this field.
Yeah.
Because the stigma is there. Like, we don't want to talk about it because we don't want people to start using drugs, as the way they say it, drugs based on there's an evidence that, people might think, which is to some degree, it might be the case.
Yeah.
If you think a lot of people, I'll give you an example. We talked about the drug delivery system, which is, I see it it's much more, with much more potential and help than what we've done in cannabis. But the cannabis one, that's the one that took the momentum. And everybody's talking about it. And I get questions every day till today from the public, because everybody is interested, not just interested to know about cancer and what treatment we can offer for cancer, but also a lot of people, they like or they use cannabis just for fun.
Yep.
And they see, wow, we're the right people then. I don't know if you agree with me. Do you know what I mean?
Yeah.
We're not doing something wrong.
Yeah. Yep.
You know what I mean?
Yep.
And fair enough. It's like, but you've got to understand, we're not talking about THC here.
Yep.
We're not talking about smoking
the
that it has.
The psychoactive component.
Yeah, and when we talk that, you mix it with tobacco, you have 1,000 different carcinogenics involved in that.
Yes.
So it's a huge difference between smoking and between medicinal cannabinoids.
Yes.
Medicinal cannabinoids still suffers from this stigma.
Yep.
And we see this. Now, to win and how government needs supposed to handle this, there's a big question. In Australia, we're still having a serious problem. And I got approached by different platforms that they're trying to deregulate cannabis.
Yep.
And to do something about it. But a lot of them said to me, you know what, we don't have that big hope.
Yep.
In Germany, cannabinoids were deregulated in the 1st of April this year.
Okay.
When did that happen? And I received the report from my brother who lives in Germany, and another person also who doesn't know me and sent it to me. He's from Israel. Oh. He knew that I'm Israeli, so he sent me that thing.
Where in Germany does he live?
In Düsseldorf.
Okay.
Yeah, he practices in Heinsberg dentistry, but he's in Düsseldorf.
Because I lived in Nuremberg for a little while as well.
He's all of his life, Munich, Aachen, Düsseldorf.
Yeah. Yeah.
But what happened in Germany when they produced that what do you call it, review as or a press review, press release about the deregulation, they put it. My research came out from Australia, talking about the benefits of cannabis to support their release. And that's in Germany, where they're not far from the Netherlands, so they have to justify a lot of stuff to get it out there.
Right.
And just a couple of months ago. And again, in Europe, we're more open to this. In Australia, we still have a lot of restrictions. Fair enough, because it needs a lot of research, needs a lot of stuff to happen. But in a country like Israel, we do have this. We have a very strict, different ethnic groups there. We have the Palestinians. They live in Israel. They are also very traditional, so they don't accept this. We have the Haredim, very strong, very influential, and they don't accept that. So the secular part, they're the minority, I would say, in a country like Israel. That's why even if Professor Meshulam, who is the one who came up with the idea, we have seen that, from the 60s, we're talking about like 60 years ago.
Yeah.
And we're still so behind. Do you know what I mean?
Yeah.
Just recently, we start gaining momentum.
That's right. That's why I asked that sort of question. Yeah.
And definitely because of this stigmatism.
Yes.
About the whole topic.
Yeah.
You're dealing with drugs. You know what I mean?
Yeah.
In the bad sense.
Yeah.
You know, if we agree with that or we don't agree, that's a different matter. But the influence is there and needs to be handled properly. Of course, the authorities, they need to take care of that.
Yeah.
And to have it under control, you know, to release these things. We might have a problem like, you know, a lot of people from religious background, they don't want to take the medicine if we have a medicine out of cannabis.
Sure.
Do you know what I mean? Exactly the way we talked about vaccines.
Yep.
So that's another thing we need to think about it. What's going to be the commercialization status for this medicine if it's out there one day?
Yeah.
You know what I mean? But interesting.
You made one interesting point before that I wanted to ask you about, and that was that these, I don't know if it's molecules, but there's these characteristics or something of the cannabis plant that we also have within us.
In our system, yeah.
So does that mean that we're inexorably linked some way with, with the cannabis plant? Is it like some sort of divine...
This is a very philosophical question.
Yeah, it is, yeah.
I don't know if we can go into that.
Well, if
a biologist,
if you don't have time, we'll have to get you back on another time to answer it. But you know, is that what? Well, I guess I should maybe frame it like: is that a very common thing? So with other plants, for example, that we have specific or similar traits or characteristics.
That goes back to the evolution theory,
right?
And I personally, as a biologist, as a scientist,
you're everything.
I agree with a lot of that.
Yeah.
And we look at the origin of the genome we have on this planet, that it has one source.
Right.
And if you look at similarities and differences between different species or different, what we call it, families of creatures, or when we talk about species, we talk about interbreeding members.
Right.
And we're talking about family, we're talking about humans and chimpanzees.
Okay.
But we're talking about also now plants and animals. But interestingly, we found there are certain similarities when it comes to the genome. We talked about one of the things that I investigated in the past, and I wrote a book chapter about it, is alternatives to antibiotics. And alternative to antibiotics, and that's why we started with this before even. And one of the peptides I tested with this drug delivery system was a peptide related to what we call it lactoferrin that we produce in our milk.
Right.
Which is a natural peptide, and that will protect the kids when they get born, or the infants, before they start getting antibiotics. That's why we have immune system. That's part of our innate immune system. These peptides and proteins, we found it on plants. Similar proteins, similar peptides, similar mechanism of defense against insects, against fungus that attacks plants. So they have, and we use these days, we're trying to get some of these peptides to defend our systems from bacteria which is resistant to antibiotics.
Yeah.
Exactly the way we use gentamicin, which is a peptide-based molecule. We use it intravenously when somebody has severe infection in hospitals, which we extracted from organic products, not from humans and not from, so there is genetically, I'm not an expert to go through that, but as I said personally, and from what I read, and also what I studied in biology in my early career, I believe, there is something. That's why it's not really surprising me to have same what we call it endocannabinoid system, and we had similar system when we talk about endorphins and morphine. Right. Morphine or opium produced from opium.
Yep.
And works for us because we have because there's a similarity.
Yes.
It does attach to the same receptors where our body produce certain neurotransmitters to help us to forget about pain or to relieve pain.
Fascinating.
So,
Well, I won't keep you any more of your time, Dr. Nassar. Like I could honestly listen to you speak for hours, but I understand you're probably a busy man and need to get back to work. We do give our guests an opportunity to just plug something or make an ask. I think you mentioned earlier that you were still looking for funding for one of your projects. If you want to take a minute or two just to, explain that.
please. In science needs a lot of support. And unfortunately, science and scientists are neglected by a lot. Comes from the government or from the public.
Sure.
I remember when the COVID started, everybody was looking, where are the scientists? Why they don't come up with something kind of immediately to help us?
Yep.
Everybody was scared. And I remember this professor from Barcelona. She said, why you guys going to go to, and she mentioned one of the football players, to give you support rather than asking a scientist who live on $80,000 a year to invent something for you immediately.
Yeah.
So bottom line, one of the main things that we suffer from is lack of funds. We do have strong universities in Australia, but that's because we have close to 650,000 students coming from overseas to study in Australia and pay lots of money. And that's why we get our universities to hire good lecturers and good researchers and to pay them good money. And that what puts Australian universities in the top 500 universities all around the world.
Right.
And we have 5 universities in Australia, top 50 universities in the world. So, but we still, with all that, we still suffer. We build our education system based on teaching more than research. Research is essential, and as you can see, research is pretty much, that's what give us a longer lifespan.
Yeah.
Give us people live in their 90s free of bad diseases these days, and they enjoy their lives. And to keep doing that and to improve it further, of course, we need some money so we can buy our consumables. We can buy some of these cannabinoids or cellulose or things like that, and pay a scholarship or a wage for very little amount of money for somebody who's doing PhD. PhDs these days, they get through their studies, if they get scholarship, they get about $32,000, and sometimes they have to go and work outside to be able. Like some of these guys, they married and they have families.
Yeah.
How are you going to support that if you don't have the right resources to attract students? We're having a major problem. Most of our students, they're doing PhDs in Australian universities, are from overseas. They're based on the scholarship they get from their governments, and after that they go back to their places or their countries and they work there. But we run out of scientists here in Australia because to ask a young guy who finished pharmacy to come and do some research, say, well, I earn from pharmacy $80,000 to $100,000 a year. Why I should come and do some work in your lab and you pay me just $30,000? What makes you think that you can get me, to do that work?
Sure.
So to attract these students, probably we need to, and there is some programs that we can increase their scholarship or they increase their support up to $50,000. To do these things, we're looking for always charities, pharmaceutical companies, spin-off companies that, they have some money and they want to develop something, and they can, instead of they running their R&D section, they can basically hire us as scientists for their own projects, and that help us to get students to buy our consumables and to do the research and to advance the pharmaceutical industry and science in general here in Australia.
Yeah, because it sounds like it's critical work that you guys are doing that could, change
Yeah, and
humanity, essentially.
exactly. And the problem is, I blame scientists in that because they don't try to translate what they do to the public.
Right. It's a messaging problem.
Yeah. My philosophy when it comes to this, beside pushing boundaries and sharing knowledge and excellence in research, also to look at the public and to look at the interest of the society in science. And to do that, you need to be able to talk the language, to translate it to not to keep it in a very scientific, very technical terms that people cannot understand it sometimes. You need to be able to translate it and to deliver it to these people. To
make it digestible.
And that's where you get support.
Right.
So I'm not blaming the government or just the public. They're not having interest in that. Also, we are scientists. We need to be able to translate what we do to the public, so to attract these funds and to make science better.
But is that also a societal thing where we don't appreciate as much the work that researchers do?
We don't, because we don't understand. We don't know it.
Okay.
Probably from what I described today or explained, or from our conversation, yourself found it fascinating because you didn't know a lot of these things before.
Yes, absolutely.
And some of the stuff, public, they should know. They should understand what's the difference between FDA and TGA, how we get our medicines approved here. A lot of people, they come into the farm and say, well, I've seen these medicines in Europe and in America. Why we don't have it here? Do you know what I mean? So we need to have this system, or maybe to have a platform with a collaboration with the government or other bodies, to where we can explain, and then when public start understand what we're doing, then they will appreciate it more. But public understand and they get entertainment from football these days more than science. Unless another disaster happen, and then everybody start thinking,
where are the scientists? Yeah, what are they doing?
What are they doing? Why they're not doing their work? They don't understand what's happening behind the scenes. You know what I mean?
Yeah, no, well, that all makes sense. Dr. Nassar, we might leave it there.
Thank you very much.
Best of luck with all your future research. It's absolutely fascinating. I mean, I'm sincere when I say I could listen to you speak for hours. And if you have time, I'd love to have you back on, maybe to talk about, or we could talk about philosophy if you wanted to, but things like psilocybin mushrooms and therapeutic side of things, PTSD and MDMA. I understand there's research being done in those areas. But that's a whole other sort of kettle of fish. But I really appreciate your time, and
thank you.
Hope that you can find the research dollars you're looking for.
Thanks for giving me the opportunity to come and talk to the people.
Yeah, thanks, mate.
Thank you.
All the best.
Thanks a lot.
Cheers. Thanks, everyone.
Cheers.